طيب يعطيكم العافية شباب. We are in lecture 25, stresses due to surcharge. As we said in previous lecture, stresses due to surcharge, to load, is a function of load, soil type, soil structure, soil properties, soil consistency, plasticity limits, water content, everything about the soil. Okay? Depth, distance, and contact surface, in addition to some other variables. Okay? Now we said that two persons tried to solve this problem, trying to eliminate as much of these unknowns as they can. These two people are Boussinesq and Westergaard. Okay? We have the solution of Boussinesq and Westergaard in your textbook for every condition. But we will deal with Boussinesq. Okay? Unless I tell you solve it according to Westergaard, you have to solve it according to Boussinesq. Okay? Always according to Boussinesq. The difference is minor between them. The same equation, only some of these constants are different. Okay. Now let us go first to review. We did some review, some strength of materials review. Stresses on a plane, normal and shear stress. As we said that if we have an element, and this element is under equilibrium, so it has loads acting on it, right? Okay? Suppose this is sigma y because it's in the y direction, so this is sigma y. This is sigma x because it's in the x direction, so this is sigma x. And this is tau xy, under equilibrium. So as you see, the summation of sigma y is 0, the summation of sigma x is 0, and the summation of moment is 0. This moment is going against this moment, right? Now suppose this point is A, B, C, D. These are the acting forces on these planes. Okay? Now, if I am trying to find the stresses on an inclined plane, that plane is EF. Okay? Again, this is A, B, C, D, and this is EF, which is inclined by the angle theta. Okay? We take a free body diagram, as you see here. Free body diagram. This free body diagram is E, F, and this is B, right? So this is sigma x, tau xy. And this is sigma tau xy, sorry. And this is sigma y. Now, in the inclined plane, we will have two forces. One is perpendicular and the other is tangent, okay? So this is sigma n and this is tau n, okay? We said that let us try to eliminate as much unknowns as we can, okay? So we can say that EB equals to EF cosine theta, right? EB is EF cosine theta, and FB is EF sine theta, right? Knowing this, we go to try to sum forces on the direction of n. Summation of forces in the direction of n is 0. Where is n? Here is n. This is the n direction, okay? And this is the t direction, okay? On the n direction, as you see that we have sigma n going down, while all other forces are going up, okay? If the sum of them is 0, then the one is going down equal to all the others, right? Okay, so it means sigma n going down multiplied by the plane that it acts on it, which is EF, the inclined plane, EF, equals to sigma x multiplied by FB. But FB is EF sine theta, again multiplied by sine theta, so sine square theta, right? Plus sigma y EF cosine square theta, plus 2 tau xy EF sine theta cosine theta. We can omit EF. And at the end we end up with this equation, which we said that is important. sigma n equals to summation of sigma y plus sigma x divided by 2 plus the difference between sigma y and sigma x divided by 2 cosine 2 theta plus tau xy sine 2 theta. This is an important equation, okay? I think we reached here. This is an important equation. You don't need to write it now. I will write it to you later. Now, if we took summation of forces on the t direction, here is t direction, okay? Let us see. On the t direction, if we took t direction as positive, for example, tau ny, tau n, this is positive, right? Tau n is positive. Then look at me. Look here, because you may do some mistakes. Okay, tau n is positive. Okay, what is also in the same direction as tau n? Sigma x can be positive, right? Tau xy will be negative. Sigma y will be negative. Okay, while tau xy will be positive. So we have forces positive, we have forces negative. Okay, so now we will do it like this. Summation of forces in the direction of t equals 0. What do we have? We have tau n, the main force, remember, tau n multiplied by the plane EF equals 2. Remember sigma x, we said it goes on the same direction. So if we put equals, then it will be on the other side, it will be negative, right? Are you with me? Anybody is sleeping? Anybody is snoring? Anybody is snoring? You don't know what's snoring. بشخور يعني بالإنجليزي. No snoring. Okay. Tau n multiplied by EF. So it will be minus sigma x multiplied by EF sine theta cosine theta. Let us go back. Okay, sigma x. Okay, sigma x is in the same direction. So when it goes to the other side of the equation, it will be minus, right? Okay. Minus sigma x. This is FB. FB we decided EF sine theta, right? EF sine theta. EF sine theta. And to go here, we have to multiply by cosine theta. So it will be sine cosine theta. You see? EF sine theta cosine theta. The same way, it was minus sigma y, so it will be plus sigma y. Sigma y, EF sine theta cosine theta. The same thing. Now the tau force, there are two forces. In the previous example here, they were in the same direction, but here one goes in one direction, the other goes in the other direction. So we cannot put them 2 tau xy. We have to put one of them minus, one of them plus. Minus tau xy EF cosine square theta plus tau xy EF sine 2 theta, sine square theta. Okay? You can try this at home with 2 sandwiches of hamburger and 2 pieces of pizza and 3 cups of tea. I think you will understand it. Okay? Don't take hamburger. Now, if we try to eliminate the similar portion of this equation, we end up with this equation. Tau n equals sigma y minus sigma x divided by 2 sine 2 theta minus tau xy cosine 2 theta. This is the second important equation. So what do we have? We have 2 equations, right? What are these 2 equations? Here are they, and you can write them now. Write them, they are important. Put them in a frame. Okay? Put them in a frame. Put them in a frame. Sigma n equals to sigma y plus sigma x divided by 2 plus sigma y minus sigma x divided by 2 cosine 2 theta plus tau xy sine 2 theta. while tau n equals to sigma y minus sigma x divided by 2 sine 2 theta minus tau xy cosine 2 theta. They are very important. Put them in a frame and leave a space for another two equations. Okay? Sigma n tau n. Leave a space under it. 3-4 lines. Okay? 3-4 lines. Okay, now let us ask you a question, although the answer is written. Can sigma n equals can sigma n be 0? No. Why? Because if sine 2 theta equals to 0, so this will be 0, right? If cosine 2 theta equals to 0, then this will be 0. But still, this one cannot be 0, so it will remain, right? Sigma y plus sigma x divided by 2. These values cannot be 0. So sigma n, it is impossible to have sigma n to be 0. Okay? While tau n, it may equal to 0. Why? Because cosine 2 theta equals 0, then this will be 0. Sine 2 theta equals 0, then this will go 0. Okay?
كيف بدها تكون ساين نفس الزاوية ثيتا ساينها 0 وكوساينها 0.
We may have an angle where cosine 2 theta and sine 2 theta equals to 0, then this will end up with 0. Okay? So, mathematically, if 2 theta give us sine cosine 0, this will end up with 0 tau. But here, in all cases, whatever, we still have sigma y plus sigma x divided by 2, right? So, sigma n, it is impossible for sigma n to be 0, while it is possible for tau n to be 0, right? Tau n may be 0. It may be equal to 0. Tau n can be 0 at certain theta. I don't know what kind of theta. But let us use the same equation. Then tau n equals to 0, which is sigma y minus sigma x by 2 sine 2 theta, tau xy cosine 2 theta, right? So this will be 0. Or in another word, I can say that sigma y minus sigma x divided by 2 sine 2 theta, I mean this portion will be equal to that portion, right? Sigma y minus sigma x divided by 2 sine 2 theta equals to tau xy cosine 2 theta. Or tan 2 theta, because it's sine over cosine, right? It will be equal to 2 tau xy divided by sigma x. This is important. What angle, you asked me? There is no such angle. No. When I have tan 2 theta equals to 2 tau xy divided by sigma y minus sigma x, then I will end up with tau equals 0. Okay? It means tau equals 0, it means I don't have shear stress. So, tan 2 theta equals 2 tau xy divided by sigma x minus sigma y, right? Okay. This is important. This equation will give us, when we have tau xy equals to 0, at this stage we will have 2 sigma n, not 1. Why? Because theta, which will give us 2 tau theta equals to 0, it will be repeated every 90 degrees. Remember? Remember the relation between 30 degree and 150? Remember? Okay. So this theta will be repeated every 90 degrees. Then we can say this. This equation will give us two values of sigma, okay, which are 90 degrees apart. Okay? They are repeated every 90 degrees. They are repeated every 90 degrees. So I can say This means that we have two planes perpendicular to each other with different values of sigma n, and where we have shear stress tau equals to 0. So at 90 degrees, two planes at 90 degrees, what we will have? We will have tau equals 0, sigma n we have two values. Okay? One value is great and one value is small. Okay? So that's why we call them major principal stress and minor principal stress. What is major principal stress? It's sigma n, right? Sigma n, and we will call it from now on sigma 1. From now on it will be called sigma 1, okay? What does it mean? Sigma 1 equals sigma y plus sigma x divided by 2 plus square root of, this is, remember, that is square, okay? Sigma y plus sigma x divided by 2 plus the square root of sigma y minus sigma x divided by 2 up to the square power plus tau xy square power, okay? And the minor principal stress, which we will call it from now on sigma 3, okay? Now when I say sigma 1, you will know that sigma 1 is this value. It's sigma n. It's normal stress. Sigma 3 is the minor normal stress. Sigma y plus sigma x, etc. This is square, of course, and this is square. What is the difference between them? You see, they are the same values, but we have here plus, we have here minus. Okay, so we ended up with having 4 equations. See, summary. These are 4 equations. You can put them together. They are very important. So we have 4 equations that will help us finding sigma n tau n, right? What I can know? I can find sigma n, tau n, and at the same time, if the shear equals to 0, I will have sigma 1 and sigma 3. Major principal stress and minor principal stress. At that time, tau is 0. Okay? So if I give you a question, such this question, for example, this question, and ask you to find sigma n tau n and sigma 1 and sigma 3 when the shear equals to 0, I can use these 4 equations. Okay?
And the tau xy is 0?
Yes. I will tell you later. Okay? Not tau xy, sorry. Tau n. Tau n, not tau xy. Tau n. Tau n is different than tau xy. Okay? We have 4 equations. So I can give you a question like this and ask you to find, please, those. What you will do? You will use these 4 equations and solve the problem, right? Some people don't like to use this equation. They like to use what we call it Mohr circle. Okay? What is Mohr circle? Remember these 2 equations, these 4 equations. Remember them, okay? We can find 4 equations, sigma n, tau n, sigma 1, and sigma 3 by drawing Mohr circle. Who is Mohr? Mohr. Yes, he's German. Mohr circles. It's a way to solve the problems by drawing. By drawing. Very easy way. Mohr circle. I know that you skipped it, right? Nobody explained Mohr circles to you, right? So can you concentrate? I will explain it to you and you will find it interesting, simple. Although in the exams it may make some problems, but it's not that problem. Okay? When you are ready, I will concentrate to explain to you, not for me. Ready? Ready? Okay. Wake up, concentrate. We will use Mohr circle. For what? To solve these problems. First of all, we will try to find sigma 1 and sigma 3. Sigma 1 and sigma 3. Okay? Now, Mohr circle, it means that we have two axes. This axis is sigma, and this axis is tau. Okay? Normal stress and tau, and shear stress. Yes? Okay. Now, first thing, if you remember, the equation is two parts. See? This part, and this part. Right? They are the same. You see? They are the same. Sigma y plus sigma x divided by 2, sigma y, sigma x plus divided by 2, right? Square root, square root. There is no difference between, so their values are the same. But here we have plus, here we have minus. Okay? So if I find this value and added to it the square root, or I found it subtracted the root, square root, so I will have 2 points apart, the same thing from each other, right? So that's what we did. Look, I found this value, this point. What is this point? It is sigma y plus sigma x divided by 2, okay? I find sigma y 13, sigma x 25. So 13 plus 25 divided by 2, and I put it on this stress, on the normal stress, on this axis, right? Because it's normal stress. Okay? So this will be the point which represents sigma y plus sigma x divided by 2, right? Now, to find sigma 1, we added the square root, right? This is the square root. When we add it, then we have this point. What is this point? When we subtracted it, it's the same values. Then we have sigma 3, right? So what do we have now? We have a circle with a diameter equals sigma 1 minus sigma 3, okay? Or with a radius equals to square root, right? The point, the origin point is sigma y plus sigma x divided by 2. This is the origin. And then we have to draw a circle with a radius equals to square root, right? So I have the square root this way. Then I'll put on the center and I will draw a line. Easy, right? Okay? What did we do? We found the point of origin, which is sigma y plus sigma x divided by 2, point of origin, right? We found the square root, we added, and then subtracted it. Okay? When we added it, we have sigma 1. When we subtracted it, we found sigma 3. So this will give us the diameter of the circle. So I can draw the circle. Now I have a circle. This is Mohr circle. Easy? Okay, not difficult. Before we continue, let us have sign convention, okay? Sign convention. You can write it also in your book somewhere or on your textbook somewhere, because it's different than what you have in structure or reinforced concrete or strength of materials or whatever else. Guys, compression is positive. Tension is negative. Why? You see, there is a philosophy behind deciding what is compression, what is tension, what is negative, what is positive. For us, driving the car on the right side of the street is the right way. But if you go to Britain, it's the wrong way. Right? Who's right? Who's right? Both right. Okay? Because in Britain they used to this. So if you drive according to your way, this will make a problem. Okay? In Bulgaria, if you said this, it means no. And this means yes. And you try, you will have a problem, right? See? They have different signs. So there is a philosophy of using what is negative, what is positive. And by the way, we now know that there are a lot of problems there, okay, in using what is negative. For example, all our clocks, they are moving, what we call it, clockwise. But the clockwise is wrong. The new watches, they should go differently, counterclockwise. Like Earth, like all our planets, like our blood in our body, like in the electrons in the atom, like people when they make pilgrimage in Mecca move. Everything in the world, everything in the universe, everything in your body or in the cells even moves to the right. So now they are trying, those who study astronomists, okay, they are calling for watch that goes clockwise, okay, counterclockwise, sorry. Watches should move differently, the opposite, okay, and even they should consider Mecca as the Greenwich line, not the Greenwich, because only in Mecca the sun will be perpendicular to the Al-Kaaba, okay, with no shadows at all, while in Greenwich it's deviated by 7 degrees in Arabic. هلا الآن علماء الفلك بيطالبوا باعتماد خط مكة هو خط الصفر الدولي اللي بينحسب عليه، لأنه هو الخط الوحيد اللي بتتعامد معه الشمس وبتعطيني ما فيش ظل مرتين في السنة. كتبت الساين كونفنشن، مهم جدا هذا لأنه على أساسه إحنا هنحسب. طيب. Two methods for using مور سيركل. يا شباب المور سيركل بإمكاننا نحل الأربع معادلات اللي حكيناها، صح ولا لا؟ الأربع معادلات بإمكاننا نحلهم باستخدام إيش؟ المور سيركل. في عندي طريقتين، الطريقة الأولى اسمها إيش؟ origin method. origin إيش يعني origin؟ أصل. أصل. شو أشهر كتاب بيبدأ بكلمة origin؟ شو كتاب داروين الشهير؟ Origin of Species، أصل المخلوقات، أصل الكائنات، اللي هي كتب فيه نظرية التطور. ما قريتوها؟ ولا طيب كيفكم تصدقوها ولا ما تصدقوهاش؟ بالعائل؟ أي عائل وأنت مش قارئ؟ هي طبعا بده يكون في صعوبة، إذا قمت الطاقية بتصير بسهولة. يا شباب Origin of Species، الكتاب اللي ألفه داروين لما سافر على السفينة بيجل، سافر فيها على جزر الجلاباجوز. ما أخذتوها؟ في أيامنا كانت مقررة بالإنجليزي. وين ورقة الأسماء؟ مخبيها، بتظبط لي إياها. Origin method. Origin يعني أصل، مش هيك؟ وأصل الدائرة شو هو؟ مركزها، صح ولا لا؟ The center. That's why we use it. Okay, origin method. Here is the origin method. We will draw a circle like this. Okay. The other method is Paul method. What is Paul? Paul. He's the uncle of Matthew. No, this is not Paul. That's Paul. P-A-U-L. Paul. In some countries it's Paul. Paul. In some other countries Pavel. Pavel. هو Paul. Pavel. ما سمعتش في Pavel Korchagin؟ اللي ألف قصة كاك زكلالة ستال. طيب يا شباب. Paul method و origin method. اوكي. الآن كيف نشرحهم؟ نخليها للحصة الجاية لأن الموضوع حياخد وقت كتير، فبنكتفي بهذا القدر. يعطيني العافية.